Hello everyone, welcome to Elevare. This is Fahim, and today we'll be solving this October 2025 Unit 1 Variant A paper from chemistry. So without wasting any more time, let's just solve this down. So in the first question, just a moment. So basically in the first question, it says that which of the element is in the D block of the periodic table. Now let's just go to the periodic table once. Okay. So in the periodic table, we could see that these elements are what we refer to as S block elements. These elements, on the other hand, this transition metal one, okay, let me just do it clearly. These are your S block elements. This, on the other hand, is your D block elements, and these elements, on the other hand, are your P block elements. Now, if you were asked to write the electronic configuration in SPD notation, you'd see that for this group 1 and 2, it ends in S, and for this, it ends in D, and for this, it ends in P. Hence, it belongs to S group, D group, and accordingly, P group as well. Okay, so this basically is the question. So let's just get back to it. So from here, we could see that argon is in group 8, this is in group 7, this is in group 1. Hence, our answer should be iron, because iron is basically in group D of the periodic table. It is also a transition metal. Okay, moving on. Some of the ionic radii are shown. Which compound has the strongest ionic bonding? Okay, so for something to have the strongest ionic bonding, we basically need to know that the radius of that compound, the radius for something to have strongest ionic bonding, the radius should be the least. The radius should be the least. Why? This is because as per Coulomb's law, if q1 times q2 pi r square, right? As the radius decreases, the force of attraction increases, right? And hence, the one that has the smallest radius for both the cation and the anion would have the strongest ionic bonding among themselves. Now, what I know that is both potassium and sodium. They both are group 1 elements. However, the radius of this is smaller, which means that the charge density of sodium is greater than that of potassium. Okay, and for the anion, I'm gonna select this. So sodium fluoride, as it has the smallest radius among all, would have the greatest amount of strength in their ionic bonding. So sodium fluoride should be our answer to this question. Moving on. So which of the pair of electrons are isoelectronic? So what basically means what is the basic meaning of this term? So they have same number of electrons, you could say. Same electron numbers. Same. They have the same number of electrons. And these are basically what we refer to as isoelectronic, right? Now, we know that for calcium, the atomic number is the atomic number for calcium is 20. Since it has a charge of +2, it means that it lost its 2 electron, right? So this should now be 18. And for sulfur, the atomic number, the atomic number is 16. But since it has a charge of 2 minus, it means that it gained a surplus amount of 2 electrons. So it has a total of 18 electrons, right? Since both of these has the same number of electrons, so they both are isoelectronic ions, and hence A should be our answer to this question. So yeah. Moving on to question 4. It says that a 2 kg sample of water, a 2 kg sample of water contains 40 parts per million by mass of nitrate ions. What is basically the mass in grams of nitrate ions in this sample? Okay, so easy question. So what we have to do is, first of all, write the formula of ppm. ppm as the formula of this, the mass of solute, mass of solute, the mass of solvent times 10 to the power 6. Okay, now what I could see from here is that the mass of water is 2 kg, right? However, you have to convert this unit in grams. So what you're going to do is 2 times 2000, 2 times 1000. So the mass of this is 2000 grams. So this is the mass of solvent or the mass of water. You have your value of ppm given, that is 40. Now you put all of this value into this equation and you make this the subject, and hence you'll be getting your answer. Okay. So what I could see from here is that 40 is equivalent to mass solute, and the mass of solvent is 2000 into 10 to the power 6, right? So therefore, make mass of solute the subject, mass of solute. So we'd be getting what? We'd be getting 40 times 2000 divided by 10 to the power 6, right? If you do this, your answer should be 40 times 2000 divided by 10 to the power 6. Your answer should be 0.08. Now there's a catch. All of your answers are in standard form. So you have to convert this answer to standard form as well, right? So 1, 2. So this thing would basically mean that the answer of this is 8 into 10 to the power minus 2. 8 into 10 to the power minus 2. So A should be the answer for this question. I hope you all are clear with this, okay? So yeah. So moving on to question number 5. Uh, what is the atom economy? Okay, another basic question and another common question as well. So what is the atom economy by mass for the formation of iron? So this iron is basically your desired product, okay? So how do you figure this out? How do you figure the atom economy of something, right? So the atom economy of something has a formula of this. Atom economy, atom economy. So the atom economy of something is atom economy equals to the MR, the MR of what? The desired product divided by the MR of all product, and you multiply this value. Oh, you do not have to multiply this value by 100. Okay. So this is the formula of atom economy, right? So what we know from the top is that iron is being produced, right? And the MR of iron is 55.8. 55.8. And the total MR is iron plus carbon dioxide, right? Iron is 55.8. 55.8 plus 12 plus 2 oxygen, 16 times 2. 16 times 2. Now if we do this, let's just check the value of it. 55.8. 55.8 plus 12 plus 16 times 2. You get a value of 0.559. 0.559. Okay? 0.559. You get a value of it. Now, oh, okay, sorry. I have made two mistakes over here. I have made two mistakes over here. First of all, I won't say anything. Try to figure this out on your own. I intentionally messed up some of the stuff. Okay? Since you have been believing every single thing, now figure the mistake out. Do let me know in the comment section, okay? Do let me know what are the mistakes in the comment section for these, okay? Let's just see. Either you watched up to this attentively or not, or you are skimming through the video. First of all, you have to multiply this value by 100. So the formula of atom economy is this. We have to multiply this value by 100 first of all. This is the first thing. Okay? Now there is this another mistake. Figure that out. There are two iron being produced and three carbon dioxide being produced. So you have to take this value into mind while carrying out this entire procedure. Times 2. 2 times, okay, this is getting kind of messy. So let me just write this down. 55.8 times 2 plus carbon dioxide is 44 times what? 3. 44 times 3, and what you have to do is you have to multiply this overall value by 100. If you do it, let's just do this. 55.8 times 2 divided by 55.8 times 2 plus 44 times 3 times 100. So you should be getting a percentage of 45.8%. 45.8%. So your answer should be what? Your answer should be 45.8. Now if you were to do the earlier calculation that I showed you, you should have gotten an answer of 55.9, which was completely wrong. Okay, so you have to take into mind while solving this question. Okay, now moving on to the next question. So in question 6, it says that a sample of hydrated calcium sulfate has a formula of this was heated to constant mass. 3.405 gram of calcium sulfate was produced, and this mass of water was produced. What basically is the value of x? Now this basically is another common question that you will encounter in your exam scenario. Okay, so let's solve this. CaSO4, and over here you have your water, H2O. Okay, now the mass of CaSO4 is 3.405. 3.405, and the mass of water being produced over here is 0.900. 0.900. Okay, so you have to divide this. Okay, the molar mass for CaSO4 is what? 136.2. They're making our lives easier. 136.2 divided by water is 18. Okay, so let's just try to solve this. 3.405 divided by 136.2. So you should be getting a value of 0.025 over here, and 0.900 divided by 18, you should be getting a value of 0.05 over here. Now, which one is the smallest value? This one, right? Now you're going to divide both of these with the smallest value you have, 0.025, and over here the same thing is going to repeat itself, 0.025. And if you do this, you should be getting a ratio of 1 to what? 0.05 divided 0.0251 to 2, right? So therefore the value of x, the value of x should be 2, and our answer should be B. Okay, B should be our answer to this question, 2. Okay, moving on, everyone. I hope you all are clear with this. Now, how many orbitals are there in total in first three quantum shells? In first three quantum shells of an atom, and how many orbitals are there? Okay, so let's just see it, right? So it would be better if I was to draw the atom itself. Okay, so this basically is the nucleus of the atom. This is the nucleus. Let's just draw the shells first, second. Okay, this is in the shape that I want. Second and third shell. Okay, first, second, and third shell respectively. Okay, so first is, over here we have S, SP, SP, D, right? We have S, and then in the second we have SP, and in the third we have SPD, right? So for S, we have, only one orbital, and for P, we have a total of three orbitals, right? For S, we have one orbital, and for P, we have a total of three orbitals. One, two, three, right? So this is for S, and this is for P. Now, how many S do we have? 1, 2, 3, right? It means that 3 times this. Now, how many P we have? 1, 2. So, 2 times this, right? So, let me just write this down while solving this question. Times 3 times 2. And for D, the number of orbitals is going to be 5. Oops. 5, right? 1, 2, 3, 4, 5, right? And this is gonna be D. And how many D orbitals do we have? We have only one of it, right? So 3, 2, and one of it, right? So calculate this down. So 3 times is, right? So S orbital. So for S orbital, we have total number of 3. 2 times P, right? In 1P, there are these 3 orbitals. So in 2P, there is going to be a total of how many orbitals? 6 orbitals, right? So 2 times 3, that is going to be 6. And in 1P, there are 3 orbitals. And for D, we have how many orbitals? 1, 2, 3, 4, 5. And for D, we have a total of, and for D, we have a total of 5 orbitals, right? So you sum all of the values, 6 plus 3 plus 5. Uh, Let me just do 6 plus 3 plus 5, and you should be getting a value of 14 orbitals in total. Okay, so the answer for this question should be D, everyone. I hope you all are clear with this. If you aren't, then do let me know in the comment section. Okay, so which of these forms of carbon does not contain a delocalized electron? Graphite does. That's why it is a conductor. So does graphene. So does 6. Diamond doesn't, right? Diamond doesn't. Why? Because in diamond, one carbon is bonded to four other carbon atoms. In diamond, one carbon is basically bonded to four other carbon atoms in a tetrahedral structure. I'm just showing you one of the example. The same thing goes for this carbon as well, okay? Now the thing is, a carbon has a maximum number of 4 electrons in its outermost shell. Since all of the electrons are bonded and hence it does not have any free electrons, okay? Moving on. Now which molecule is polar? Which molecule is polar? So while you are trying to figure out either a molecule is polar or not, you have to keep in mind about one thing. If the dipole moment if the dipole moments adds up, then the molecule is polar. If the dipole moment adds If the dipole moment adds up, then the molecule is polar. Now, what I want you to do is you basically have to draw the shape for all of this. So let's just start drawing for this. So for BF3 boron, boron is in group 3, right? Boron is in group 3, so it has 3 bond pairs. So this is going to have a structure of trigonal planar, okay? So for boron, the structure is going to be trigonal planar. Boron, the structure is going to be trigonal planar. If F and F over here, right? Now, which one is more electronegative, boron or fluorine? Fluorine is more electronegative. So there is basically a table for electronegativity. Now you have to understand, you have to memorize that entire table for electronegativity, right? Now in this covalent bond, the boron is giving one electron, and so is our fluorine, and the fluorine is giving one electron, right? Now based on the electronegativity of the element, fluorine would be having a higher electronegativity, hence it would be pulling these electrons towards itself, and it could be represented by this arrow, and this arrow is what we refer to as a dipole moment, right? Now you draw the dipole moment for all of this. See, these two dipole moments are canceling one another out, and hence this isn't a polar molecule. For this, you're going to do in the same way. This is going to have a tetrahedral structure. So in the middle, you have your carbon, fluorine, 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 fluorine. Now the thing is that fluorine is more electronegative than carbon, so it would be pulling the electron towards itself, like those bonding electrons towards itself, and the dipole moments would look something like this. Now you could see one thing pretty clearly. See, this thing and this thing is canceling one another out. Hence, this isn't a polar molecule as well. Now for oxygen, oxygen has 6 electrons in the outer shell. It is bonded to fluorine, so 2 of the electrons are gone. So it means that it has a surplus amount of 2 electrons, right? So one was given to fluorine, one was given to fluorine. So 1, 2, 3, 4, 5, 6, right? So as it has 6 electrons in the outer shell, 2 of it are already bonded to fluorine, right? So you have a surplus amount of 2 electrons left, right? And this type of shape is what we refer to as this type of shape is what we refer to as V or bend shape. V or bend shape. Okay. So let's just draw this V or bend shape. These are the lone pairs. Over here we have one. Over there we have one. Fluorine, fluorine. Now, fluorine is way more electronegative than oxygen, so hence it would be pulling the electrons towards itself. Fluorine is the first electronegative element out there. He's the boss of everything. Now, what I could see from here is that this and this dipole moments are adding one another out, right? They are reinforcing themselves, and hence this is a polar molecule. So our answer should be C. Okay, moving on to the next question, question number 10. A pure alkane fuel is burned. Which of the substances is not a possible combustion product? Okay, so whenever you're burning something in the presence of oxygen, let's just say X, or let's just say an alkane. So whenever an alkane burns in the presence of oxygen, it leads to the formation of carbon dioxide and water. Now this was burned. Now in this reaction, it was burned in the presence of sufficient oxygen. Now when you have insufficient amount of oxygen being present, then it is going to lead to the production of carbon monoxide, which is basically a toxic gas and reduces the ability of the hemoglobin to carry oxygen, right? So this and this would be produced, but not hydrogen. So our answer of this question should be A. Okay. Which of the compound has the greatest covalent character? So for something to have the greatest covalent characteristic, there needs to be two criteria. So what are the two criterias? So first criteria is that the first criteria is that so for something to have the greatest amount of covalent characteristic, there are certain criterias. First is that there needs to be a that polarizing effect, or there has to be greater amount of polarization that is taking place, right? And the polarization effect depends on two things. First, charge density of the cation, charge density, and this is for the cation. And the second one is the radius of the anion, the radius of the anion, radius of the anion, radius of the anion. So for cations that have the greatest amount of charge density would have the highest amount of polarizing power as well. And for anions that have the greatest amount of radius, it is going to be easier for the cation to pull that outer electron towards itself. Right now, let's just think of something like this. So this is basically the cation, and this is basically the anion. The cation should be having a smaller radius as well, right? Because if the radius decreases, the force of attraction is obviously going to increase, right? Now there's this electron. Now let's just assume that there is this electron. Okay, there is this electron. Now these are basically perfect ionic compounds, but here's the twist. Here's the twist to it. This is the cation. This is the anion. So this cation is basically having an attraction for this anion, and what it to do is it to try to pull this anion towards itself. Now the larger the anion, the larger the radius of the anion, the weaker would be the force of attraction between the nucleus and the electrons for that anion. Okay, so the larger the anion, the weaker would be this force of attraction, and as a result it would be easier for this cation to pull the electron towards itself. So if I was to redraw this, it would be looking something like this. Let me just redraw this once more, everyone. Just a moment. Okay, now if I was to redraw this, it should look something like this. Oops. If I was to redraw this, it should look something like this. Now, these are an perfect ionic agent, right? So yeah, this is what I refer to as having increased amount of covalent characteristic. Okay, so criteria: magnesium and barium, right? Barium is larger, radius should be smaller. Okay, radius of the cation should be smaller. So, but for magnesium, for fluorine and iodine, right? Iodine is larger. So it would have greater polarizing effect. It would be greater polarizable. Iodine would be more polarizable than fluorine. So our answer should be B. 11B. Okay, everyone? So moving on to the next question. Everyone. So in this question, it says that some equation for reaction used in reforming crude oil fractions are shown. Which of the equation is not balanced? Okay. So first of all, for this type of questions, label everything down. Carbon, 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 carbon. Over here we have carbon, 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 carbon. Now label the hydrogens. These are the hydrogens, okay? Now, if you have question like why these dots, because a carbon could have a maximum of 4 bonds, right? So see, it have already bonded to one carbon, right? So it has 3 more free spots, so 3 more bond with hydrogen, okay? 3 more bonds with hydrogen. So same thing would happen over here as well. So let's just calculate the number of hydrogen over here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 hydrogen over here. 16 hydrogen. And how many carbon do we have over here? 1, 2, 3, 4, 5, 6, 7. We have 7 carbon and 16 hydrogen. We have 7 carbon over here. So let's just calculate the number of carbon again. 1, 2, 3, 4, 5, 6, 7. 7 carbon. And how many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Again, we have 16 hydrogen over here. So yeah, this is balanced. Now, you do the same for this and this as well, right? Since I have been doing this for quite a while now, I could basically understand by taking a look at the appearance, you could say. So this one isn't balanced. So let's just try to figure this out. So, but in your exam hall, you basically have to draw all of it, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 10, 11, 12, 13, 14, 15, 16. Carbon, 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 carbon. Okay, so 1, 2, 3 hydrogen. For this carbon, there is a catch. That is, it is bonded. It is bonded to this double bond. 3 bonds. Okay, so it could basically take a maximum of 1 surplus bonding with hydrogen. And for this carbon, 1, 2, 3, it has bonds. Okay, so let's just calculate the number of hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 hydrogen. And how many oxygen do we have over here? We have 1, 2, sorry, how many carbon? 1, 2, 3, 4, 5, 6, 7. We have 7 carbon over here. 7 carbon. Okay, now let's just figure out the number of hydrogen over here. 1, 2, 3, 4, 5, 6, 7, 8, right? 8 plus 6. So 8 plus 6, this should be giving a value of 14. So we have 14 hydrogen over here. Now, the number of hydrogen over here and the number of hydrogen over here, they are in balance. So our answer should be D. Question 13 says that what is the IUPAC name of this compound? Okay, so what is the longest carbon chain? We have 2 carbon over here. So we have 2 carbon. 1, 2, 3, 4, 5, 6. So our name should be containing hexane, right? 6, right? Let me just check over 1, 2, 3, 4, 5. 1, 2, 3. So our longest chain is hexane, right? So you could eliminate this pentanes, okay? Hexane. Now, this is carbon 1. Now, 1 and 2, right? This isn't the number of carbon, right? This entire thing is considered to be one carbon, okay? This isn't the position. The position of it is going to be 1, first position, second, third, 4, 4, fifth position, right? We have two methyl groups over here and over here. We have basically two methyl groups, one over here and one over here. So 1, 2, 3, 4. So 2, 4 dimethylhexane. So 2, 4 dimethylhexane. So our answer for this question should be C. Okay, moving on to the next question. What is the percentage by mass of nitrogen? What is the percentage by mass of nitrogen in this? Okay, so this is simple. MR of nitrogen divided by the total MR of the compound times 100. How many nitrogen we have over here? 2 nitrogen, right? So 14 times 2 divided by 4 plus 28 plus 16 times 3. This is the entire MR, right? And if you do this, you should get a value of 35%. So our answer over here should be D. Moving on to the next question. Uh, the chemical properties of an element is determined by what? So chemical properties, right? Obviously the number of electrons, and hence the answer is going to be electronic configuration. So in question number 16, it says that the empirical formula of the oxide form. What is the empirical form of the oxide form when 2.6 gram of chromium reacts with pure oxygen to form 3.8 grams of chromium oxide? Okay. So what should be the answer of it, right? So we basically know the mass of oxide, the entire mass of oxide, okay? And we also know the mass of chromium. So what we could do is we could figure out the mass of oxygen. So the mass of oxygen should be equivalent to 3.8 minus 2.6. 3.8 minus 2.6. So this should be giving you a value of 3.8 3.8 minus 2.6. This should be giving you a value of 1.2 grams. Okay. Now you have it, right? Now what you're going to do is you're going to construct the table and figure out the molar ratio and so on. You're done, basically done with it. Okay. Easy question. So chromium, these are oxygen. So 2.6 is the mass of it, and the MR of it is what? 52. 52. On the other hand, 1.2 divided by 16. 1.2 divided by 16. So yeah, 2.6 divided by 52. So this should be giving you a value of 0.05. And over here, you're going to have 1.2 divided by 16. This should be giving a value of 0.075. We are going to divide by the smallest one, this one. So 0.05 over here, and then 0.05 over here. So you're having a ratio of 1 to, that one is 0.075 divided by 0.05. So 1 is to 1.5, right? Now you have to basically make this a whole number. So what you're going to do is you're going to multiply this thing with 2. So you have a ratio of 1 to 2, which means that CR 1 to 3. 1.5 times 2 is 3, right? So CR2O3. You have a ratio of 2 to 3, right? So the answer from here should be C, CR2O3. Okay, so C should be the answer of this question. Moving on to question number 17. Question number 17. Identify an atom with unpaired electrons. An atom with unpaired electrons in the lowest energy state. Okay, in the lowest energy state with two unpaired electron in the lowest energy state. Okay, so for barium, this is in for barium, just a moment. Barium is in group 2, right? So it has basically two electrons in the outer shell, right? So it has two electrons in the outer shell. So for barium, if I were to write the electronic configuration, then it should be 1 is 2, 2 is 2. And since there are 2 electrons in the S subshell, it should be looking something like this. For S subshell only, okay? So for S subshell, it should look something like this. And this is paired, okay? So this isn't gonna work. Let's just check for carbon. Carbon is in group 4. So it has 6 electron, right? So 1 is 2, 2 is 2, 2p, 3. 2p, 3, right? Now let's just draw this p subshell. Right? 2p3. Oh no, wait. Hold on. 4, 2 to 4, 2p2. Right? So this should be this and this, right? So we basically have two electrons, right? Two unpaired electrons. Two unpaired electrons. See, we have basically two unpaired electrons. So the answer should be B. Understood? It said that two unpaired electrons and hence carbon is our answer. We have two unpaired electrons. Now, which compound has an empirical formula that is different from the molecular formula? Okay. So let's just figure out the molecular formula first. Carbon, 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 carbon. 1, 2, 3, 4. These are hydrogen basically, because one carbon can do a maximum of 4 bonds. One bond is here, one bond is here. So the other bonds should be hydrogen. Okay. So 1, 2, 3, 4, 5. So C5, H what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, H10. H10. Now this was the molecular formula. Now the empirical formula should be CH2, right? So the molecular formula is different from the empirical formula for this A only, okay? Now, if you do the same thing for B, C, and D, it basically will be the same, right? Empirical formula and molecular formula for all of these would be the same, right? Now let's just check one more example. One, 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 1, 2, 3, right? So how many carbon are there? 1, 2, 3, 4, 5. We have 5 carbons, so C5. And how many hydrogen are there? C5. And how many hydrogen are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12 hydrogen, H12. H12, right? We have 12 hydrogen and 5 carbon. 12 hydrogen and 5 carbon. Now you basically cannot simplify these up, right? So it has the same molecular formula and the empirical formula, okay? So A should be the answer, okay? Moving on. Chlorine can be prepared by the reaction with concentrated hydrochloric acid and concentrated sodium chlorate, okay? The chlorine is a hazardous substance, and the risks due to chlorine is best lowered by using a fume cupboard, okay? Because it is basically a toxic gas. Now, this is a really common question for Unit 2. So, Unit 1, Unit 3 as well. So, yeah, you should be knowing this. Metallic bonding is best described as the electrostatic force of attraction between the cations and the delocalized electrons. Between the what? Nuclei and the shed between the cations and the delocalized electrons. Okay, so assume that these are the metals. These are the metals. Let's just take a look at it. Okay, let me help you to visualize this. Okay, so these are the metals, right? These are the metals. Okay, so these are the metals, right? And among these metals, suppose these are the delocalized electrons. C, C, and so on. Okay, positive ions. Now, metallic bonding is best described as the electrostatic force of attraction between these cations and the electrons, okay? So, yeah, everyone, this brings us to the MCQ section from this paper, okay? I hope you found this video to be helpful. If you did find this, then make sure to like, comment, and subscribe to our channel for the next parts of this session, okay? Have a great day, everyone. All the best.